Hi class, in lesson 1.1 you will be learning about factors and multiples. Learning targets for today, you will list factor pairs of numbers and relate factors, multiples, and divisibility. Key terms to look for in lesson 1.1: array, factor pair, factor, commutative property of multiplication, distinct factors, perfect square, multiple, and divisible. Please turn to page 4, problem 1, Kenya's rings. Kenya has a collection of 18 rings and she wants to store them in a box. She uses an array that groups her collection into 2 rows, with each row having 9 rings. An array is a rectangular arrangement that has an equal number of objects in each row and an equal number of objects in each column. Please answer number 1, letters A and B with your group. For number 1, letter A, possible arrays that you could have created: 9 rows of 2, 1 row of 18, 18 rows of 1, 3 rows of 6, and 6 rows of 3. For letter B, the math operations that you could have thought about when you created your arrays were multiplication and division. Please answer letter C and letter D with your group. For letter C, yes, there is more than one way in both examples. For the first example, the arrays with 2 rings in a column or row are 2 by 9 and 9 by 2. And for the second example, the arrays with 3 rings in a column or row are 3 by 6 and 6 by 3. For letter D, you know that you have determined all the arrays for a number when there are no other numbers that divide into that number evenly, or when there are no other numbers that you can multiply together to get that number. Please turn to page 5. Kenya notices that the number of rings she used in her rows and columns are the same as the factor pairs of 18. A factor pair is 2 natural numbers other than 0 that are multiplied together to produce another number. Each number in a factor pair is a factor of the product. Please answer number 2, letters A through D with your group. For number 2, letter A, the factor pairs that can be used to group Kenya's rings are 1 and 18, 2 and 9, 3 and 6, 6 and 3, 9 and 2, and 18 and 1. For letter B, the factor pairs represent the rows and columns that are in the arrays that we created back in question 1. For letter C, you can use multiplication and division to determine the factor pairs. And for letter D, you can determine which numbers divide evenly into 18 and which numbers you can multiply together that result in a product of 18. Kenya notices that the array of 2 rows of 9 rings is different from the array of 9 rows of 2 rings. However, when she multiplies the factor pairs for these groupings, the product is the same. In a multiplication sentence, this means 2 times 9 is equal to 9 times 2. The factor pair of 9 and 2 is equal to the factor pair of 2 and 9. This is an example of a very important property called the commutative property of multiplication. The commutative property of multiplication states that changing the order of 2 or more factors does not change the product. For any numbers a and b, a times b is equal to b times a. Please turn to page 6. Mr. Rubenstein asked the class to write all of the distinct factors that appear in Kenya's arrays for the number 18. Distinct factors are factors that appear only once in a list. Please answer number 5 and number 6 with your group. For number 5, the distinct factors of 18 are 1, 2, 3, 6, 9, and 18. For number 6, factors are the divisors of a product. Factor pairs are the factors that, when multiplied together, result in a specific product. Please answer number 7 with your group. For number 7, Abdul is going to be correct. There are 6 distinct factors. For the number 20, Aaron is confusing factor pairs with distinct factors. He is counting each distinct factor twice. Please answer number 8, letter A, with your group. The distinct factors of 20 are 1, 2, 4, 5, 10, and 20. And here is an example of what your rainbow diagram should look like. Please turn to page 7 and answer number 9, letter A, with your group. For number 9, letter A, 6 does not have a partner because it multiplies by itself to get the product of 36. Please turn to page 8. A number that is the product of a distinct factor multiplied by itself is called a perfect square. The number 36 is a perfect square because 6 is a distinct factor of 36, and 6 times 6 is equal to 36. Please answer number 10, letters A, B, and C with your group. For letter A, 25 is going to be our perfect square. For letter B, the factors in order from least to greatest are 1, 5, and 25. And this is how you should have created your rainbow diagram. And for letter C, 5 multiplies by itself. Please turn to page 12, problem 3, exploring multiples. Number 1, Buy-Right Produce and Vitamin Store sells juice cartons. Each carton contains 12 cans of orange juice. Please answer number 1, letters A through C with your group. For number 1, letter A, you will have 12 cans of juice, B, 24 cans of juice, and C, 84 cans of juice. Please answer number 2 and number 3 with your group. For number 2, you can multiply the number of cartons by 12 because you know that there are 12 cans in each carton. And for number 3, 12 is a factor of each of the total numbers of cans because 12 is the number of cans in one carton. You must multiply 12 by the number of cartons to get a product of 12, 24, or 84, depending on the number of cartons. Therefore, 12 is a factor of each product. Please turn to page 13. When you multiply 12 by any other number, you get a multiple of 12. A multiple is the product of a given whole number and another whole number. Please answer number 4 and 5 with your group. For number 4, 3 possible multiples of 12 are 12, 24, and 36. And for number 5, no, you cannot buy exactly 54 juice cans because 54 is not a multiple of 12. Please answer number 6 with your group. For number 6, you must purchase 16 cartons. If you need to purchase 192 juice cans, you can divide 192 by 12 in order to determine that you need 16 cartons. This will conclude lesson 1.1 on factors and multiples. Please let me know if you have any questions. Thanks.